Welcome to LIB Academy. How do we solve this problem? Well, we are going to apply the idea of beta functions here. And this is particularly, we are going to be solving trig problems. Before we continue, let's look at the general formula for trig problem as far as beta functions are concerned. So we have half beta of mn should be equal to integral from 0 to pi on 2 sine 2m minus 1 theta cos 2n minus 1 theta theta. So this is the formula that we are going to be using as far as trig functions are concerned in beta problems. So our main idea is to try and evaluate this expression here, that it will be common to this general formula here, so we can compare exponent here and look for the values of n and n. So we can replace it here and find half beta of m and n, which will be the solution to the problem given. So now looking at this, we have a term, a cos term, but we don't have a sine term. This one is definitely a trig problem, right? So because we don't have a sine term, it means we should equate those powers to 0, right? So we have cos term, and cos term, comparing this to the general formula, 2n minus 1 should be equal to the exponent of cos, so that we get to know our value, the value for n, right? So 2n minus 1 should be equal to minus 6. So we don't have, so let's simplify this. So n cross n, we have 2n equals 7, right? So dividing through by 2, we have n to be 7 on 2. So, and because we don't have a term for sine, let's equate 2m minus 1 equals 0. That's what you generally do if you don't have the term for the other trig function, cos and sine. So crossing 2m minus 1 crossing become positive 1. So dividing through by 2, we have our m to be 1. And this will tell you, this will give you a hint that if we don't have the other term, it's likely to contribute this. And one formula we'll be using here too is Euler's reflection formula, which simply states that beta of n and 1 minus n to give us pi over sine n pi. So now that we are here, we now know the value for m and n, right? So it means that our half beta of m and n should be of this form, right? So, and our half beta of m, which is half 7 on 2. It doesn't matter how you arrange it, either 7 on 2 first or 1 on 2 first. This obeys linearity, the linearity of beta problems, that beta of m n equal to beta of n m, so it doesn't matter. So let's continue. 1 on half beta 1 to 7 to should be equal to this whole problem here. So it means the value that we get for this, because we obtain m and n from this value, at the end of the day, the solution, the value that we get for this will be the solution for this problem. So now we focus on this and solve this. And the relation between beta and gamma function, we can use that one to solve this problem. And at the same time too, there can be a point where we can use Euler's reflection formula. And now at a point, this one might be the way to get our solution easier. So now the relation between beta and gamma function is that beta of n equal gamma n all on gamma m plus n. So this should tell us that half beta 1 on 2 7 on 2 equal gamma half gamma 7 on 2 all on gamma half plus 7 on 2. Sorry. And gamma half is a constant, is square root of pi. So we are going to get square root of pi gamma 7 on 2. Half plus 1 on 2 plus 7 on 2 is gamma 4. Don't forget the half here is multiplying everything here. But for now, let's keep that one aside when we get our value for this term. For the sake of, I don't want this video to get lengthy, I have a video on how to find gamma of terms like this. So, but I'm going to introduce you to the shortcut for this. So, shortcut for this, just type 7 on 2, 7 on 2, then subtract 1 from it, whatever you get, you write. So, we are solving gamma 7 on 2. So, gamma 7 on 2, 5 on 2, then subtract 1 from it again. You continue subtracting 1 from it after a point that you will get half, or you will get your first negative number, then you stop. That one is not included. So subtract 1 from it again, you get an half, right? Subtract 1 from it again, negative number, so stop, don't go further again. So your last value is half, so gamma half. Don't forget we have square root of pi here, square root of pi. So, and gamma 4, if you can express it, that we have gamma n plus 1 or to n factorial. So you can express 4 in a form 3 plus 1, then it should be, the solution for this will be 3 factorial, right? So let's say we have gamma 5. If we express it in the form 4 plus 1, which is the same as 5, so the solution should be 4 factorial, right? So if we have gamma 8 and you express it in the form of 7 plus 1, then your final solution will be 7 factorial. So gamma 4 is 3 factorial. So multiplying 5 on 2 by this will give you 15 on 8. So we are going to get 15 on 8 square root of pi all on 6. 3 factorial is the same as 3 by 2, which is 6. Now let me start writing this here. I know it's not that one. So divided by 6. Now let's bring our half. If you forget the half, you are going to get different thing altogether. So now, and this gamma half here too is also going to contribute another square root of pi. So we're supposed to get another square root of pi here, which at the end of the day is going to be, let me bring it here before, square root of pi here. So at the end of the day, we are going to get square root of pi multiplying square root of pi, which is going to give us square root of pi squared, right? All on 6, multiplying on half, multiplying by half. So we are going to get 15 on 8 pi all on 6 multiplied by half. So focusing on the numerical aspect, let's say we have 15 over 8 all divided by 6 multiplied by half. So if we express this on your calculator, if you type this on your calculator, you are going to get 45 on 8. So, and 45 on 8, Now let's bring our pi. So the whole of this, looking at the numerical part, we are going to get 45 on 8 pi. So this will be our final answer for this problem. See you in my next video, and thank you for watching.